Hello students, welcome to the review lecture 13, and in this lecture we're going to talk about some major functions that we're going to use this semester. And so the first function that is easy to comprehend is y equals to x. And what do we know about this function? If we use small table, 0, 0 will be the values for x and y. Because if we take x equals 0, y will be also 0. If we take x equals 1, y will be also 1. And so we draw a straight line through these 2 points. This is one function. For y equals to x squared, again, we can trace x and y. We can use 0 and 0. Because if we plug in 0 and we square it, we're going to get 0 for y. If we plug in 1 for x and square it, we're going to get 1 for y. The same will happen for negative 1 and 1, because negative 1 squared is also 1. And maybe a few more points. If we take 2 and squared, we're going to get 4. So this point over here. And if we use negative 2, we're also going to get 4. And so you trace this function up and to the right and up to the left, and that's your shape. So what about y equals to x cubed? If we use 0, we're going to get 0. If we use 1, 1 cubed is 1. So it's probably not that easy to see on this picture. So somewhere over here probably. And if we use negative 1 cubed is negative 1. So it's over here. And 2 more points probably. 2 cubed is 8. And negative 2 is negative 8. So if this is 2 and this is 8. And if this is negative 2, this is negative 8. Something like this, maybe a little bit further down here. All right, so this function grows really quickly and goes down really quickly, and it keeps going, and it keeps going. What else is important? 1 over x, it's a little bit more complicated. We're going to talk about these functions later in the semester, but just for simplicity, let's put few points. We can't use x equals 0 because x equals 0 is not in the domain of the function. But we can use 1, and if we use 1 and divide 1 by 1, we're going to get this point over here. And if we use 2, for 2, we're going to get 1/2. So if you go to 2, you over here at 1/2. And if you use 1/2, if you divide 1 by 1/2, you have to take a reciprocal of 1/2. So it's going to be 1 times 2 over 1. So you're going to get 2. So basically, if you go to 1/2 over here, it will go up to 2. And the same thing you do on the left side. So this is 1 over x shape. How about square root of x? So we have x and y. If we use 0, we're going to get 0. If we use 1, square root of 1 is 1. And unfortunately, 2 is not really a good number because square root of 2 is hard to calculate. But let's use 4 because square root of 4 is 2. So if we go 1, 2, 3, 4, we're going to go up to 2. And the last function that we have on this screen is cube root of x. So if we have x and y, so if we use 0, cube root of 0 is 0. If we use 1, cube root of 1 is 1. Cube root of 1 is 1. Then it's not really easy to deal with, so you have to go all the way to 8, because cube root of 8 is 2, since 2 cubed is 8, right? So somewhere beyond this, somewhere over here at 2. So maybe I made a mistake here. Maybe this is 1, and this is 1. So it's scaled a little bit. All right, so this is our function. So basically you create some points, you trace it out, but it's better probably to remember the shapes for these functions. What can we do with this function? So basically next topic is new functions from old. new functions from old. All right, so let's try to see how you can create new functions by using old functions. First thing we're gonna do, so we have some function f of x. Here we're gonna perform some action, and here is the result, and then explanation of what happened. So for example, if you take a function f of x and add constant at the end of it, it's gonna move your function that many units up. And there is a small example over here. I grabbed these pictures from the book. So what you have an original function x squared, you add 2 at the end. That means you take each point and you shift it 2 units up. So you take the point, you shift 2 units up. Take the point, shift 2 units up. Take the point, shift 2 units up. And that's what happens if you add constant at the end of the function. If you subtract constant from the end of the function, it will do the opposite. It will take a function and it will move it c units down. So if you have an original function of x squared over here, and you subtract 2 at the end, it will take this point and it will move the function 2 units down. It will take this point, it will move it 2 units down, move it 2 units down. So if you subtract c from the end, it moves your graph down. Now, can we add c directly to x? So basically, if you take original x and you substitute it by x plus c, it will take your graph and it will shift it 2 c units to the left. So let's look at our example. We take x and we substitute it by x plus 2. So that's what happened over here. We took x, and instead of x, we plugged in x plus 2. So you take each point and you shift it 2 units to the left. Take a point, shift it 2 units to the left. Take a point, shift it 2 units to the left. So every point is shifted 2 units to the left if you add c directly to x. If you take c and directly subtract from x, it will do the opposite. It will take your graph and it will shift it c units to the right. So if you take original x squared and we substitute it by x minus 2, it will take each point and it will shift it 2 units to the right. So each point gets shifted 2 units to the right. All right, so these are horizontal and vertical shifts. So I wrote up here's an example over here which says sketch the graphs of square root of x minus 3 and square root of x plus 3. So that means we're going to start with the square root of x function, and we'll plot it in black, but then we're going to shift it and we'll decide whether horizontally or vertically. All right, so if you have square root of x and you want to get square root of x minus 3, you have to substitute x by x minus 3. So what will it do? It will shift your graph 3 units to the right. So let's plot square root of x. So we know at 0 it's 0, at 1 it is 1, and at 4 it is 2. So we have this kind of a graph, and this is square root of x. And suppose in red we're going to do square root of x minus 3, which shifts each point 3 units to the right. So we count. The point on the bottom will go to 3, then this point will travel over here to 4, and this point will also travel 3 units to the right. So 5, 6, and 7. So it will travel over here. So we have the same graph, which is shifted 3 units to the right. This is square root of x minus 3. All right, now let's try to plot square root of x, but from square root of x we'll try to get square root of x plus 3. So what happened, we substituted x by x plus 3, and that means we're going to shift 3 units to the left. So in blue we'll have the graph. So that means this point travels -1, -2, -3, so it will be over here. Then this point travels over here, and this point travels 3 units to the right, so it will be over here. So we'll get something like this. So plus means move to the left, minus means move to the right. That was the horizontal shift. Okay, and next example, tells us to sketch the graph of x squared minus 4x plus 5. Unfortunately, it's not really clear what to use here, but let's suppose we're going to start with x squared. And we'd like to figure out shifts, but from this formula, it's not really clear. So what we're going to do, we're going to complete the square. So we're going to complete the square. So what does it mean again? If you remember, we're going to combine these two terms together. And so we're going to take this term and we're going to divide by 2, and we're going to square it, and we're going to add it. But since we added something, we have to subtract the same expression. And plus 5 just travels over here. So now we're going to simplify this. So we have x squared minus 4x. 4 divided by 2 is 2, and 2 squared is 4. So we have plus 4 minus 4 plus 5. And this 3 terms is a complete square, right? This 3 terms is a complete square, so we can think of 4 as 2 squared. So basically we have x minus 2 quantity squared plus 1. Why plus 1? Because we add negative 4 and 5. So what does it mean for us? We're going to start with x squared graph. Then we're going to take it and move it 2 units to the right, and then we're going to shift it up 1 unit. So let's do this. So 1, 1. Right, this is our x squared graph. So we're going to use red color to move it 2 units to the right. So it travels 1, 2. This point travels over here, and this point travels over here. So this is 1, 2, 3. So it will be over here. So we'll get the same graph shifted 2 units to the right. So let's write it down. This is x squared. The red one is x minus 2 squared. The last thing to do is to take the graph and move it 1 unit up. So this point goes 1 unit, this point goes 1 unit, and this point goes 1 unit. So we have this green graph, which is x minus 2 quantity squared plus 1. So here we had to complete the square in order to shift the graph right and 1 unit up. 2 units right and 1 unit up. Next idea is reflection. So reflection can go across the x-axis and across the y-axis. Some people say about or with respect to the axis, but let's see how it goes. So if we take x and substitute it by negative x, it will take each value that was on the right and move it as a mirror image to the left. And each value that was on the left as a mirror image to the right. So let's look at this original function, which is square root of x. And this is the mirror that we have, and it's a mirror image. So basically this point goes directly across, this point goes directly across, and so on. So it's a mirror image. If we fold the paper along the y-axis, they will match up. And this is a vertical reflection across the y-axis. If we take the whole function f of x and multiply it by -1, so basically we introduce the minus in front of the whole things that we have, this would take all the positive values and it will make them negative. But if it will take all of the negative values and it will make them positive. So look what happens. We have square root of x over here, and each point goes as a mirror image across the x-axis. All right, and so basically if you fold your paper along the x-axis, these two graphs will match up. All right, so I have a small example over here, which is cube root of 2 minus x. So we want to plot cube root of 2 minus x, and we're going to start with cube root of x. Then we're going to create cube root of minus x, and then we're going to create cube root of minus x plus 2. All right, of minus x plus 2. I think I made a small mistake over here. The mistake that I've made is I want to have minus x plus 2, but what this actually means, this means that if a factor minus out, I don't think I said it wrong, but I just didn't explain well. So let's try to see what's going to happen. We have negative x minus 2, right? It's a factor minus. So basically we substitute each x over here by x minus 2 in order to get this expression. All right. So let's try to do that. So square cube root of x. Cube root of x is again goes like this. Right, goes like that. All right, so main important points are here and here, which are 1 and 1, and negative 1 and negative 1. So what we're going to do, we're going to substitute x by negative x. That means it's a reflection with respect to the y-axis. So for this, we're going to use the red color. So this point goes as a mirror image to the left, and this point goes as a mirror image to the right. So we have the same kind of a graph, which is reflected across the y-axis. So now we're going to take each x and substitute it by x minus 2. And when substitute by x minus 2, we take the red graph and we shift it 2 units to the right. So we'll use the green color. Maybe I'll write over here cube root of negative x. This is cube root of x. And now the green one, we're going to take this point and we're going to shift it 2 units to the right, 2 units to the right, and 2 units to the right. So we get the same kind of a shape, but shifted 2 units to the right, and this is 2. Okay, so this green function is cube root of 2 minus x. All right, which is exactly this expression over here. So we did this exercise. The next one says plot this function. So our initial start is absolute value of x. Then we're going to substitute x by x minus 2. Then we're going to put a minus in front of the whole thing over here. So it's negative x minus 2. So x minus 2. And the last thing we're going to do, we're going to add 4 at the end of the function. We're going to add 4 at the end. So let's try to do that. So we will start with absolute value of x graph, which we know goes like this. We learned it in the previous lectures. So here we have 0, here we have 1, and we have 1, negative 1. All right, so we're going to take this graph, we're going to shift it 2 units to the right. So it will go over here. 2 units to the right. This point will go 2 units to the right, and this point will go 2 units to the right. So we'll have the same graph shifted 2 units to the right. Then we want to introduce minus in front of the whole function. That means it's a reflection across the x-axis. So basically, this point will stay, this point will be mirror reflection down, and this point will be the mirror reflection down, and this would be our graph, which is negative x minus 2. The last thing to do is to take this graph and shift it 4 units up. So it goes 1, 2, 3, 4. This goes 1, 2, sorry, this goes 1, 2, 3, 4. And this one goes 1, 2, 3, 4. So it's the same graph, different color. So it's the same graph shifted 4 units up. So green graph is negative x minus 2 plus 4, which is exactly this expression. So if it was too fast, again, ask me questions. I'll explain it in a little bit more details. The last thing we have to discuss in this lecture is the reflection, is the stretching and compressing graphs. So what does it tell you? If you take the original function f and you take some number bigger than 1 and you multiply the graph by the number bigger than 1, it stretches your original graph in the vertical direction. So let's look at this picture over here. So what do we have? In blue color, we have x squared function. In a red color, we have 2x squared function. So what happens is we take the blue graph and we pull it up in a vertical direction. It stretches by factor of 2. All right. And in the green here, we have the function which is 1/3 of x squared. So this number over here is smaller than 1. So in this situation, the number is between 0 and 1. So what it does, it compresses the graph. So you take the blue graph and you push on it from the top to squeeze it down, and it becomes this wide function on the bottom. So the same you can do in the horizontal direction. So I took the function which is written over here. So the blue graph is x cube root of x. All right, and then the graph in green is I forgot which one I used. The graph in green, I think it's a horizontal stretch, so it's actually x over 3 and cube root of x over 3. So what happens, you pull on the side. So in this situation, you have a factor of 1/3 in front of x, right? Because you can write this as, cube root of 1/3 times x. And in a red, you have in a red we have cube root of 2x. So what happens is c is bigger than 1, it's equal to 2, so it compresses the graph. So you take the blue graph, you push it on both sides like this from the side, and you make and you compress the red graph. And for the green graph, you pull the blue one like this to the left and to the right to create a green graph. This is a quick overview of the procedures to get the new functions from old. And actually, this is almost completes our review. The only review we're going to do in the future. We'll do some small things. We'll review some small things. But the major review that we'll have to do is for trig functions, but we will do it when we need it. So next lecture starts the actual semester, and I'll see you then.